In the areas and volume and countering in model 5, in the last session we have studied about the what is the planimeter and how to use the planimeter and the formula for finding out the area of the particular plan using the planimeter. Yes, we will solve the problem on the planimeter. The calculate the area of a figure from the following readings by a planimeter with anchor point outside the figure. The initial reading is 7.875, final reading is 3.086, the m is 100 square centimeter, the 0 mark on the dial passed the fixed index marks twice in the clockwise direction. The solution, the formula is that A equal to m into fr, that is final reading minus initial reading plus or minus 10 n plus c. Here in this problem the anchor point is outside, so the c is not existed in the formula. So the n is the 0 mark of the dial is passed the fixed index marks twice means n equals to 2, then it will rotate in clockwise direction, means we can use the positive sign because of clockwise direction rotation. So we know the initial reading, final reading, m and n, and we are using the positive sign in the formula. That is A equal to m into fr minus ir plus 10n. The c is not existed because anchor point is outside the plan. So substitute the all values in this formula. That is m is given in the formula problem, that is 100 into 3.086 minus 7.875 plus 10 into 2, n equals to 2, twice the index marks will twice in clockwise direction. Okay, then the total area of the plan or figure is 1521.1 square centimeter. 1 square centimeter. Yes, this is the area of the given figure. Yes, next we will solve another one problem on the same. Calculate the area of a figure from the following readings recorded by the planimeter with anchor point is inside the figure. In the last problem we have the anchor point is outside the figure, but in this problem the anchor point is inside the figure. The initial reading is 9.918, the final reading is 4.254, m is 100, c equals to 23.521. Here c is existed because anchor point is inside the figure. It was observed that the 0 mark on the dial passed the index once in the anti-clockwise direction. This is the problem. Just we will solve the problem, this one. Here initial reading is given, m is given, the final reading is given, c is 23.521. These are the given datas. Because of c is existed because of the anchor point is inside the figure, and n equals to 1 because the dial passed the index once in a anti-clockwise direction. The negative sign, we will use the negative sign in the formula. Then n equals to 1. Just to substitute all those values in this formula, that is A equals to m into fr minus ir plus or minus 10n plus c. Here we are using the clockwise direction, we are using the positive plus side. Okay, 100 into 4.254 minus 9.918 minus minus 10 into 1. 10 into 1 plus 23.521, that equals to 785.7 square centimeter. Square centimeter. Next problem. That is, this will solve this problem. Here the area scale of the plan or figure is given. Just we will calculate the area of the field. This is a different problem, that we are using the same planimeter also here. This problem is given in the June 2012 paper for 8 marks. The problem is, the following readings were obtained when an area was measured by a planimeter. The tracing are being set to be natural scale. The initial and final readings were 2.268 and 4.582. The zero of the disc passed the index marks once in the clockwise direction. Here once means n equals to 1. The sign is positive sign because the clockwise direction. The disc will pass the index once and in clockwise direction. N equals to 1, then sign is positive sign. The anchor point was inside the figure. Inside the figure means C should be existed. C should be existed. With the value of constant C equals to 26.430. Calculate the area of the figure. First thing, we should calculate the area of the figure. If the area of the figure drawn to a scale of 1 inch equals to 64 feet, find the area of the field. Find the area of the field. So just we'll solve. These are the given datas. The initial reading is 2.268 and final reading is 4.582. N equals to 1. We'll use positive sign. C equals to 26.430. 430. Then A equals to, substitute M equals to 10. M equals to 10. Since the square arm was set to a normal scale, the value of M equals to 10. Then substitute those values. A equals to, area equals to 10 into 4.582 minus 2.268 plus 10 into 1 plus 26.430. That area will be in square inches. That is 387.44 square inches. The scale is given. This is the first part, the area of the figure. Then you should find out the area of the field. That scale is given, scale being 1 inch equals to 64 feet. Hence 1 square inch equals to 64 by 64 square feet. The 1 acre, the conversion from 1 acre to square feet equals to 33 into 33. That 1 gunta equals to 33 feet by 33 feet. That equals to 1 gunta. That multiply with the 40 guntas, then we should get the 1 acre. 1 acre in 43,560 square feet. For a 1 acre, there is a square feet means 43,560 square feet. So we'll find out the area of the field equals to 64 by 64 into 378.44. 378.44 is the area of the figure. Area of the figure or that particular area of the plan. That divided by the 1 acre. For a 1 acre, there is a 43,560 square feet. What is the area of the field? That equals to 36.39 acres. 36.39 acres. This is a one problem. Here the scale of the particular plan is given. We are finding out the area of the particular figure. Then we are converting to with scale, and we'll get the area of the field, that is 36.39 acres. Just we'll solve another one problem with a different. The following observations were made with a planimeter. In the tabular form, they have given the known area of 60 centimeters square, and initial reading and final reading. Then n equals to 0. In the second part, we have find out the unknown area. Using the unknown area, we'll find out here in the first part the area of the figure is given. There is m is not given. In the first part. In the second part, the unknown area we should find out using the given data. That is, initial reading is 8.286, final reading is 5.22, and plus 1, n equals to plus 1. The anchor point was placed outside the figure in both the cases. Outside means use positive side. The same setting of the tracing arm, calculate the multiplier constant, that is m. In the first case, we will find out the multiplier constant, that is m. Use the same multiplying constant for the second case for finding out the unknown area. The first part, the multiplier constant is, the formula is A equals to m into FR minus IR plus or minus 10n plus C. Here C is not existed, n is 0. Substituting the values, will get the area is given, that is 60 into equals to, substitute those values. 60, area is 60, m is unknown, that we want to find out. Then final reading and initial reading is given, that n equals to 0 for the first case. Just m equals to, we want to find out the m value, that equals to 10.027 square inches. This is the first part. We are finding out the multiplier constant. Next, second part, using the m value in the second part, we will find out the area of unknown area, that A equals to m. Earlier case, m what we have found out in the first part, that use here m equal to 10.027, FR is 5.220, minus initial reading is 8.286 plus n is 1 plus n, then plus 10, that equals to area equals to 69.80 square inches. This problem is asked in the June 2012 paper for 8 marks. Come to the zero circle. What is the zero circle? It is known as a circle of correction. The circle along which, if the tracing point is moved, no rotation of wheel takes place and it only slides on the paper without changing the reading, is called as a zero circle. The line joining the anchor point and the tracing point is known as the radius of zero circle, whose center remains at the anchor point A. And this is the circle. Then the area of a zero circle will be determined by the following two methods: by the formula that area of a zero circle equals to m into c. M is the multiplier constant, c is the constant. The second part, the area of a zero circle is equal to pi into L square minus 2L L1 plus R1 square. L is the length of the tracing arm. L1 is the distance between the hinge and the rail. R is the length of the anchor arm. Using these two formulas, we will find out the area of a zero circle. Next, we will solve one problem on this for finding out the zero circle. Zero circle, area of a zero circle. Determine the area of a zero circle from the following data. In the first case, the needle point is outside the figure, and second case is inside the plan. Inside the plan and outside the plan. The reading, initial and final reading is given for particular cases, and find out the zero of the dial pass the index mark twice in the anti-clockwise direction. That n value should be 2. N value should be 2, and then you use the negative sign because the anti-clockwise direction. Take m equals to 100 square centimeter. This is the problem. We'll solve. Here the given data will be m equals to 100. Initial reading equals to, in the first case, initial reading equals to 8.596, and final reading is 4.234. The needle point outside the plan, in the first case, C equals to 0, C equals to 0, N equals to 1, plus positive sign to be used with it since it is clockwise direction. Area equals to 100. M is given 100 because it is in centimeter square. 100, 4.234 minus 8.364 plus 10 into 1, that is 587 centimeter square. Needle point inside the plan. See here, we will find out the C value. C value. M is given, that is 100. For C is not given in the problem. In the second case, inside the plan, C should be existed. So C should be find out. C equals to how much? N is 2. Negative sign should be used with it since it is anti-clockwise direction. Therefore, area equals to 100. 5.443 minus 2.484 minus 10 into 2 plus C. This area is, we will find out in the first case. You should use that area here in the second case. Then C is unknown. So C should be find out. That C equals to 22.911 because there is no unit because of this is the constant. Okay. Area of a zero circle equals to M into C. M is 100 in the problem he has given. C we have found out in the second case, that is 22.911. That multiply with those two, we get the area of a zero circle equals to 2291.1 centimeter square. Thank you.